Ladies and gentlemen, our focus today is going to be on chemical reaction types. Now, what you're going to find is that there are 5 major reaction types that we're going to take a look at in class. Eventually we may get to a 6th type of chemical reaction, but there are 5 that we're going to look at today. And they're pretty easily identifiable. If you know your reactants and you know your products, you should be able to identify these fairly easily. So let's take a look and see what we've got going on for today. So our learning targets for this particular video, you should be able to understand that chemical reactions occur in a variety of different ways. You should be able to evaluate and determine the chemical reaction types of any given chemical reaction. So if I give you a reaction, you should be able to identify fairly easily what type of reaction is taking place. So really we just have 5 vocab terms for this particular video. All of them describe a particular type of chemical reaction. So we're going to look at synthesis reactions, decomposition reactions, single displacement, double displacement, and combustion. So when chemicals react with one another, they actually do it in a variety of different ways. Now typically, it's the way that is the most energy efficient for those chemical reactions to occur. However, if we add energy to a chemical reaction, we can make a lot of different and unique things happen. There are 5 primary ways in which these reactions occur. There's synthesis, decomposition, single displacement, double displacement, and combustion. So when we look at a synthesis reaction, this primarily occurs when 2 or more substances combine to form a new compound. So we have compound A and we have compound X, and they react and then they chemically bond to form AX. So the example that's given here on the right hand side is that magnesium reacts with nitrogen gas to form magnesium nitride. The easiest way to remember and identify this type of chemical reaction is if we have 2 things in our reactants and we only end up having 1 thing in our product. Synthesize means to make something, so the synthesis reaction is identified by having 2 reactants and 1 product. The decomposition reaction is just the opposite of this. So in the decomposition reaction, we have a single compound that ends up producing 2 or more simpler substances. So if you look at the example here, we have compound AX, and then it decomposes to produce 2 separate simpler substances, such as compound A and compound X. In this example, we have calcium carbonate as our reactant, and this breaks down to form calcium oxide and carbon dioxide, 2 independent and simpler substances. In a single displacement reaction, one element replaces a similar element in a compound. So for example, A plus BX. In this instance, the A swaps with the B. So A plus BX now becomes B plus AX. So the A just simply swaps with the B. Zinc reacts with copper chloride in this example to produce zinc chloride and copper. Now you need to be very aware of what you're replacing. So we need to take a look at what is alone in our reactants. And keep in mind that cations, those things that are typically positively charged, will replace cations. So for example, zinc is a metal, copper is a metal. Those 2 are typically cations and therefore will replace each other. Those are the things that are going to swap out. In the anion replacement, which is located below, you have bromine by itself. Bromine is going to switch with iodine because bromine and iodine typically form anions. That is, things that have a negative oxidation number. So as a result, you need to be very aware of what you're replacing. Typically, a good rule of thumb to remember is that metals will replace metals and nonmetals will replace nonmetals. Or, even better, anions will replace anions and cations will replace cations. So just be aware of what that's going to look like. If you end up with 2 metals together at the very end of this equation, odds are you probably did something incorrectly. An easy way to remember this is that typically you have an element and a compound in your reactants and an element and a compound in your products. Double displacement is when 2 compounds exchange ions to form 2 new compounds. So in this example we have AX plus BY, and then the X and the Y, or the A and the B, depending on how you look at it, essentially switch places. So we end up with AY plus BX. The example here is that sodium chloride reacts with silver nitrate to form sodium nitrate and silver chloride. So essentially, they just switch with one another, creating 2 new independent compounds. The best way to remember this chemical reaction is that you're going to have two compounds in your reactants and two compounds in your products. The last type of chemical reaction involves combustion reaction. Combustion reactions almost always start with a hydrocarbon. That is, a chemical compound or molecule that contains carbon and hydrogen. These always react with oxygen to produce two products, carbon dioxide and water. So it is a very specific chemical reaction, but you'll always start with the hydrocarbon. It will react with oxygen and produce carbon dioxide and water as your two products. These you need to be a little bit more careful with when balancing, and we'll see why in a later video. So let's take a look at some of these practice questions. What type of chemical reactions do you think are represented by the following? And it's also asking us to balance the chemical equation. So let's start by determining the type of chemical reaction that's present. In the first one, we have an element by itself that's reacting with a compound to produce a compound and an element by itself. Well, if you remember, that is going to be single displacement. So this first reaction here is single displacement because we have an element and a compound that react to produce a compound and an element by itself. In the second one, we have looks like a single compound and then two independent, simpler substances at the end. So that is going to be a decomposition reaction. In the last one there, we have carbon and hydrogen reacting with oxygen to produce carbon dioxide and water. So you should know that that is a combustion reaction. Okay? So we've determined the types of chemical reactions. Now let's go through and balance these bad boys. Now I'm going to do this relatively quickly because, again, we've already had our balancing video. But if we take a look at the first one, looks like I have 2 nitrates on the left and 3 on the right. Those are going to balance out to be 6. So let's put a 2 here and a 3 here. I've got 3 PBs on the left and 1 on the right. So let's put a 3 in to balance. 2 ALs on the right, 1 on the left. Let's put a 2 in to balance. Cool. That was easy. Let's look at the next one. We have 2 hydrogens and 2 hydrogens. Well, that's nice. That balances out. But our oxygens don't. We have 2 oxygens on the right and 1 on the left. So let's put a 2 in front of H2O. Now, as a result of that, we changed the number of hydrogens. We now have 4 hydrogens on the left and 2 on the right. So let's put a 2 in front of this. And now our equation is completely balanced. So let's take a look at the next one here. We have combustion reaction here. And the way I would recommend doing combustion reactions, it's a little bit different. But I would always start with carbon, then hydrogen, and balance your oxygens last. The reason I suggest oxygens last is because they occur in a couple different places in the equation, and that can make them a little bit more difficult to balance. So let's start with our carbons. We have 2 on the left and 1 on the right. So let's put a 2 in front of this one. Our hydrogens, we have 6 on the left and 2 on the right. So let's put a 3 here. Now with oxygens, we have 2 on the left. On the right hand side, we've got 4 and 3. That makes 7. Now if we remember, our coefficients have to be whole numbers. So as we think about this, I'm going to go ahead and put a placeholder with oxygen. So how many times do I have to get O2 to get to 7? That's going to be 3.5, which is not a pretty number. But when we do this and we get a 0.5, in order to actually correctly balance everything, we multiply all of our coefficients by 2. And that's going to give us a balanced chemical equation. So let's erase these and multiply them by 2. So the first one here is going to be a 2. The next one is not going to be 3.5. But a 7. The next one is not going to be a 2, but rather a 4. And then the last one, not a 3, but 6. All right, and if we actually go through and take a look at this, everything should balance out. Let's double check that. It looks like we have 4 carbons on the left and 4 carbons on the right. 2 times 6 is 12 hydrogens, and 6 times 2 is 12. We have 14 oxygens. We have 8 oxygens there and 6 there. 8 and 6 is 14. So we're completely balanced. So again, keep in mind, identifying reaction types does help you with the process of balancing and will be really important in our next video, quite possibly the most difficult video of the unit, predicting products of chemical reactions. So hopefully as a result, you understand that chemicals can react in a variety of different ways. We have a variety of different reactions that we need to take a look at. And there are 5 major types of chemical reactions: synthesis, decomposition, single displacement, double displacement, and combustion. All of them have very different and unique ways of reacting with the chemicals that are present. So hopefully by the end of this video, again, you should be able to pick up all of these things that are listed here, and we've met all those learning targets today through the video. Hopefully you've had a great day, guys. Hopefully this is pretty straightforward. We'll talk to you later and see you next time. Bye-bye, guys.